So in this video, we are going to see about recursion. Recursion is about nothing but function calling itself. So let me just copy this thing and first let me create a file. And oops, not over here. Okay, okay. So let me paste it up. Of course, like I would like you to what to say, uh, do it by hand, right? I don't know why this isn't working. In recursion.clj, okay. And save, okay. You just create another file and saving it on Clojure and saving it, save, right? Copying this entire stuff and pasting. Yeah, now it works. I don't know what's happening. Maybe there's a bug in Canva or something. I am not sure. So yes, okay. So let's see what it does. So I just have this countdown. I just load it into my Ripple, and if I just put countdown, it goes from 5, 4, 3, 2, 1. That's it. So that's the thing. And let's see how it works. Okay. So yeah. So I first call this countdown with 5. Okay. So this number becomes 5 over here, right? And it prints 5. So you get 5 over here, right? If okay, if decrement of number is positive, so the decrement of phi is nothing but okay is decrement of phi is nothing. Oops, okay. uh, Decrement of phi is nothing but 4, right? Okay, so yes, it is positive, so it goes over here, right? And so now what happens is like okay, so it goes over here. So once again, this count get called. So this countdown get called, but with decrement of number. What is decrement of number? It is 4, right? So now it gets called with 4. So it 4 goes over here. Now it prints 4 over here, right? So you get 4 over here, right? And now if decrement of number, that is decrement of 4 is nothing but 3. It's positive. So once again it goes over here, and over here, rather than passing a number, you're passing decrement of number. So 3 goes over here, it gets printed. Similarly, the decrement of 3 becomes 2, and once again this gets called, so it comes over here, and over here it gets printed. And so yeah, like once it gets printed, I'll just make my pointer larger. Right. I feel only then people can understand, can follow this better. Okay, right. So, yeah, like, okay, I think I left with 2. Okay, yeah, and 2 gets decremented to 1 and it's still positive and it gets called. And once again, it goes here, prints 1, and 1 gets decremented to 0. If you ask me positive, okay, like, okay, I don't know, right? Okay, so. EOS 0, I'm not sure. Yeah, it's false. Okay, yeah, fine. So it's false. So that's it. Like it doesn't call this countdown again, right? So this countdown keeps calling countdown again and again, and so that's how it just works. Okay, so this is called recursion, right? So that's how it is. So you just see the function called countdown, and depending on certain condition, it either calls or it just exits off. Okay, so that's how it is, right? And yeah, so this works. Okay, so okay, So there is another way to do it. Look, one thing what happens is like, okay, what I heard from what ex- I didn't experience. Okay, what I read from some Clojure documentation and all those things is calling this function name itself is kind of inefficient. That's what they say, right? You call countdown from countdown itself is kind of inefficient. They say a thing called stack. Look, don't go too much into stack and all. Okay, Clojure built something called stack and all those things, and that costs a lot of computation or memory. That's what they say. I think a lot of memory. So rather than doing that, they are telling us to use something called recur, right? If a function is calling itself, they are telling us to use a thing called recur. Okay, so let me just put a new file, right? Okay, save it as function recur, yeah, cur.clj, right? And then, okay, let me just, okay, no need to copy this. I will just take this, put it over here, and rather than this countdown, I'll just put recur. Recur means, okay, it knows that, okay, it is in this function countdown, and it calls this function itself countdown again. So they say, look, this kind of saves something called stack or memory. I'm really not sure, but yeah, this is the better way of doing it. Okay, so and okay, so yeah, okay, it's more memory efficient. Okay, uh, it is said that when we use recur, okay, it should be, it's, there is a typo. It's more memory efficient and condition. Okay, okay, it should be that. Okay, there's a lot of spelling mistakes in my book. I need to correct it. Okay, fine, right. Okay, so recur is more memory efficient, and the only thing the condition it should satisfy is it should occur at the last uh, line of the function or something like that. Okay, should be the last statement executed in the function, right? So that's the thing. Of course, over here it is at the last. Okay, so and that's the thing, right? So yeah. So now let's load it into memory, countdown, and then do the same stuff. We are getting the same stuff. Okay, so uh, yeah, that's the thing. Okay, okay. So now we are using this recur to, what to say, add numbers in a sequence, or so yeah. So let me just some using recursion. Okay, so let me just put a file, right? Okay, and paste it. Once it's run, once when I run it, I'll just explain. Okay, yeah, functions using recursion, right? Okay, sum. Okay, it's been loaded, and when I execute this, I just get 15, right? So that's how it is. But then let's see how it works. Okay, so now, okay, let me just to uncomplicate it, let me just take out this println statement. Okay, so or let me just copy this and paste it. Okay, so okay, so now, yeah, you're just getting 15, right? So that's the thing. So this one is actually println is printing 15 and it's returning nil, and this one is the sum is returning 15. Okay, so that's the thing. Okay, but yeah, in Ripple it'll also print 15. Okay, so that's how it is, right? So yeah, if that's confusing, yeah, forget about it, right? Okay, so that's the thing. So this returns 15, right? So what happens? Okay, so First, when I call this sum and this thing, actually there is no need to put commas in Clojure, right? So, okay, so that's the thing. So, okay, when I call this one, what happens is this 1, 2, 3, 4, 5 is being caught by this numbers, okay? So this number takes in this vector 1, 2, 3, 4, 5, and the total becomes 0, right? And now it checks if numbers are empty. That's not true, okay? So, like, look, if I just put like, okay, empty, and then 1, 2, 3, it'll say 4. Oops. Empty is emptying stuff. Okay, right. Okay, right. Okay, I never knew such a function existed. Okay, so it'll say false. Okay, so empty is false. Okay, so what it does is it once again goes. Okay, and it goes to recur. That means it calls sum. Okay, rest of numbers. Okay, so the rest of numbers is what? Rest of 1, 2, 3, 4, 5 is 2, 3, 4, 5. Okay, and now what is the resist? Okay, so it is like, okay, sum of, okay, so okay, like I'll just put it as vector 2, 3, 4, and 5. And what is this one? Plus total first of numbers. Okay, so what is first of numbers? Okay, so like the first of numbers is nothing but 1. Okay, and you're adding total with it, so it'll become like 0 plus 1, because initially it's 0, right? So 0 plus 1, so it is 1. Okay, so now we have reconstructed this statement. Okay, so now it is once again calling sum of 2, 3, 4, 5, and then the total is now being passed as 1 over here, right? So that's how it goes. Okay, so now over here what happens is empty of numbers is false. So once again it goes to recur. Okay, rest of numbers. Okay, so rest of numbers will be 3, 4, and 5, and then the total is 1. So and then so it should be total plus first of number. So what is the first of number over here? It's 2. So what is 1 plus 2? It's 3. 3. Okay, so that's how it is. And yeah, so and now the next step will be, okay, yeah, this is, of course, this is executing. That shouldn't be, I shouldn't be explaining like that. Okay, so what will happen in the next step? Okay, so in the next step it will be sum of okay, so the first plus this one will be 6. Okay, that will be passed as a second argument, and next you'll get 4 and 5. Okay, so that's how it is. And then in the next step, it will be like, okay, what is 6 plus 4? It's 10, and only 5 will be passed. Okay, still it's not empty because 5, this array has one value, it's called 5. Okay, so that's the thing. And then finally, what will happen is like, okay, it'll go to an empty array, and then it'll be 15 over here. Total will be 15. So if it is empty, it'll just return the total. Okay, so that's what happens. If it's empty, it just returns the total, right? So and finally, you'll just get out of the recursion, and this total will be returned. And of course, over here the total is being shown in the REPL. Over here the total is being printed in the REPL. Okay, both are kind of very similar. No need to worry so much. If you're getting confused, what's the difference between print and just executing this and getting 15 over here in the right hand side, just don't worry, right? So that's the thing, right? So that's how recursion happens. Okay, so yes. Okay, okay, so mm, now what to do if I want to write a function called collect. Okay, if I just want to sum up a collection, right? So like uh, uh okay, so right, okay, so I just want, okay, to write a function. Oops, not over here I'll just put a new file called collection sum. Okay, so that's the thing. This is the name of file. Of course, no, it's not much significant if you're learning Clojure. Okay, so I just want something like collection sum, and I should be able to put something like 1, 2, and 3. Okay, so but this for this sum, you are supposed to give something like, okay, like sum, and then 1, 2, and 3, and then initial value, possibly total is 0, right? So now, since sum can only be given like that, okay, so let me just copy it and put it over here. Just to sum up a collection, okay, so all you just need to do is like, okay, you just have sum over here, right? And collection sum, it just takes a collection and it doesn't need total. So in that way, it's more intuitive. So what it just does is, okay, like you just have a collection over here. So collection, okay, so what you just do is you just sum and you just give collection over here, and you just pass total as 0, right? So I don't know why it's showing error, unresolved symbol, collection. Okay. So I need to put define, right? So that's how it is. So yeah, now it can sum up collections. Okay. So let me just load sum up. Let me load collection sum into this Ripple. Okay. Press option enter or alt enter. Now if I just put, okay, like collection sum and then 1, 2, 3, it gives it gives 6. So all we are just doing is giving an initial value to it. That's it. Okay, so that's the thing. Okay, so that's all for recursion from my book. And until we see in next video, bye.